Hey everyone, my name's Geoff Huntley. I'm here today to tell you how to build an agent. Like, you hear this word agent all the time, agent. You're probably sick of it. But has anyone ever explained to you what it is from first principles? Like, it's not that hard, folks. It's really not that hard to build an agent. It's 300 lines of code. Because they're looking. Would you believe it's only 300 lines of code running in a loop with LLM tokens. That's all it is. 300 lines of code running in a loop with LLM tokens. You just keep throwing tokens on the loop, and then you've got yourself an agent. So today we're going to be building one. We're going to be doing it live, and I'll explain the fundamentals on how it all works. So this slide is intentionally blank because we are now in 2025. It is now the norm to have concurrency in doing work. So what better way to do 2025 than to build the agent while I do the talk? And we'll come back and have a look at it at the end of the talk. Okay, so we have a little blog post over here, how to build an agent. You can use any code tool out there. You use any coding tool out there. You could use AMP, or you could use Windsurf or Cursor or Claude Code. You can literally just say, build me an agent with this blog post, and it will build you an agent. Like, it's unhinged. At the end, I'll be giving you the workshop materials, so you can run this internally within your organization. So let's kick this off. Cool, we're now building an agent. So this is one of the things that's really changing now as the normal software development is like the fact that you can do a spike or you can build something while you're in a Zoom call, right? This is where you get this notion of concurrency, and this is how it's going to change a lot of the things that's happening in software development. This is where I do. Please build your own, folks. It's important to be engineers. It's important to understand the primitives of like what's going on. If I was to ask you what a primary key is, you should know what a primary key is. That's been a norm for a long time. Knowing how to build an agent has been like something, now what's coming in with employers is knowing how to build that agent is really important. It's like, it's the new fundamental knowledge of like what a primary key is. You still need to know what a primary key is. We also need to know how to build an agent at some employers. Because like having this knowledge will transform you from being a consumer of AI into being a producer. This is really key. They can really automate things at your company. So if you're joining me later this afternoon for closing the conference, I'll be getting into this a little bit more deeper. But you'll find yourself potentially somewhere in this journey. So up on the top left, we've got like, prove it to me, it's not real. Prove it to me, prove it to me that it's not hype. It's not good enough, not good enough, not good enough. Meanwhile, the people who are stuck up there on that left side of the cliff, completely ignoring there's people up on the right side of the cliff, completely automating their job function. So any disruption or loss of jobs related to AI is not through AI, it's through lack of personal development. And investing in yourself. The tech travelator has always moved on. Always moved on. The travelator is just moving on here, folks. So learning how to build an agent is just really key. It's like knowing what a primary key is. So my name's Geoffrey Huntley. I used to be the tech lead for developer productivity at Canva. As of a couple of months ago, I'm one of the engineers at SourceGraph building AMP code. It's a small core team of about 6 people. We build AI with AI. And AMP, Cursor, Windsurf, Claude Code, GitHub Copilot, and AMP are just lines of code running in a loop of LLM tokens. I can't stress that enough. The model does all the heavy lifting here, folks. It's the model that does it all. Like there's things that we can do as tooling providers to make all these command line and IDE plugins to give it little subtle hints, like you're running on Mac OS. You're running on this version of macOS. Oh, you're running on Windows. Well, if you're on Windows, you should use PowerShells. You should use like forward slash versus backslash. We can give it little hints, but it's the model doing all the underlying things here. So here's the key concepts. Not all LLMs are agentic. Not all LLMs are agentic. The same way that you have different types of cars, like you've got a 40 series if you want to go off-road, and then you've got like a people transporter, like combi van if you want to like transport people. Like the same thing applies to LLMs. I've been able to map it down into the behaviors of LLMs into a quadrant. If I was to say, hey, you need to do some security research, which model would you use? That'd be Grok. That's low safety. Grok is a low safety model. If you want something that's ethics aligned, it's Anthropic or OpenAI. So that's high safety. And similar, you have oracles. Oracles are on the polar opposite of agentic. Oracles are good for summarization tasks or like high level of thinking. Meanwhile, you have things like Anthropic Claude Sonnet, which is more like a little squirrel. Like it's incremental squirrel that wants to do tool calls. Models assume that they're all competing against each other, but a lot of people are just looking at the models very plainly from their costs. The idea that a model is, they're looking at a model on its cost and its context window, and that's it. It's kind of like looking at a car, whether it has 2 doors or 3 doors, 2 doors or 5 doors, without ignoring the fact that some cars are designed for off-roading and some are designed for people transport. So if you need an Oracle, O3. One of the best things out there if you want to like check the work, and you can combine these models together. That's what we do at AmpCode. We use Anthropic at the core, and you can function call over to O3 to check the work of the squirrel. The next thing that's really important to learn is you should only use the context window for one activity, folks. When you're using Cursor or any one of these tools, I can't stress this enough. How it works is you've got a very small amount of memory. Kind of think of these as kind of like the Commodore 64. And what you should be doing with it is you should be using that context window for one activity. And that activity could be like, hey, I want a new route on my back-end controller. Cool, that's that one activity. If you then start allocating memory into that context window for like rebrand the website to be Gen Z and Fluoro, well, like you just mix the topics of concerns. The way these LLMs work is needle in the haystack based on what you've allocated into the memory. Hit new chat all the time, folks, in your tools. Do it. If you're getting a bad outcome from your tools, you've probably got context window pollution. One thing for one activity. Really important, folks. You have a small amount of memory. I'm going to stress this point. Small amount of memory. It's smaller than you think. So Sonnet, 200K, cool. Well, they've got a system level model prompt that allocates memory. So you have less than you think, and then you have a tool such as Cursor, AMP, Windsurf, Claude Code, whatever. We also allocate a little bit of memory. So you do get the full context window size, but it's used a little bit by the system model, a little bit by the tool. Now, what happens when someone goes, "Oh, MCPs are hot. Yeah, I'm gonna pick and choose all the MCPs." Next thing you know, you've allocated all your usable memory because MCP is a function with a billboard on top that gets allocated to the LLM that tells how to call that function. So you find people they're picking and choosing, they're enabling all the MCPs. And what you're doing is you're just making the LLM dumber. The more you allocate into the context window, the dumber the results you get. So don't go over the board with MCP. Like, you don't need the GitHub MCP. The foundation models have been trained on how to use the GitHub command line tool. If it knows how to invoke the command line tool, you don't need the MCP, unless you're doing server to server. Okay, so this is where we get into the inner loop. Now we've done the fundamentals. An agent is 300 lines of code, roughly, running in this loop. And you notice on line 4, what we're doing is we're looking for like user input on line 3, and we're just continually just calling off for inference, and then we're just reallocating every message that's happened before in the previous conversation. We like to use the term turn. Every turn, you do a message, that's a turn. You do another message, that's another turn. Cool. Let's have a look. So meanwhile, that agent is now built in the background while I've been talking. This is why the new norms of engineering productivity are changing. So let's have a look at this particular thing. So in this, cool. So what we've got here is your baseline agent. And the baseline agent is this. We're just going to have a chat conversation. Hey everyone, it's nice of you for me to join me today. I'm currently in Sydney. Hey, how you going, Claude? You can call me Jeff. So we're going to have a little chat with a conversation. And this is the part where I'm getting a live demo failure because I invalidated my API key, which is going to be a little bit risky to do it live. If you give me approximately a minute, I'll rotate my keys. I'm so sorry for not prepping this. But the general idea is you run it in a loop. You disconnect the HDMI because you're about to provision an API key, and then you hold the space. It really is that simple, folks. Console Anthropic. I knew that would come back to hurt me. And
they haven't cut you off entirely yet?
No. I mean, I do use a bit of inferencing, folks. There we go, I've got an API key, close. Devon. And this is where we go for the fastest recovery, hopefully. Yeah, I do use a bit of inferencing, folks. My YouTube channel is full of probably 2,000 or 3,000 hours of me AFK vibe coding a new programming language while I'm down at the pub. It's not me there talking, it's literally I'm just completely on the nose. Claude building a new programming language while I'm down at the pub drinking beer. Anyway, let's see how we're going here. Do we have our split? Sweet, folks. Okay, I haven't even tested if this API key works, so let's do it live. Okay. Hey, thanks for joining me here today. Hey, Claude, my name's Jeff. Can you speak like a pirate to me and tell me what today's date is? Yay, the demo gods are doing well today. The demo gods are doing well today. So what we got here is this baseline loop where we do inferencing. We take input and we inference. This is where we start getting into this notion of tools. So when we talk about agentic, we're talking about something that's tool calling, something that has been trained on its reward function as calling a tool. There are models where they've been trained specifically. All they want to do is like a squirrel. All they want to do is chase nuts. It's not nuts, it's tools, right? So here we're going to register in some tools and explain how this all works. So if I come across over here and I have a prompt here. You're a weather expert. When I ask you about weather in a given location, I want you to reply with get weather location name. All of a sudden I've got a function here and I'm just passing into the function like the location name, a string. I will tell you what the weather is and that location is, understand? Hey, what's the weather in Sydney right now? Cool. What's the weather in San Francisco? Remember, a tool or MCP is just a function with a billboard on top. What you just saw is the billboard that instructs the LLM how to invoke that function. It's really that simple. You register the tool, you register the function, and then you go from there. Cool. This is how it works. This is the loop. This is the loop. If it wants the tool, it will call the tool. You just got to check the result of the inferencing whether the agentic model wants to call the tool. And if it does, you invoke that tool. Cool. Now this is where we get really cool, because we're going to build in some tools like Claude Code, AMP, Windsurf, Cursor. They're all these primitives. The first primitive of a coding tool is a list files tool. So it's very similar to the Weber function. And we're going to go, hey, can you tell me what files are in this file system right now? So this workshop is they all build upon each other. So we started at the chat tool, the chat interface with no tools, and now we have a list file which is registered a tool on top. Everything I go from here is going to incrementally build upon that, and all of a sudden you have a coding agent that you can use at home and play. So let's have a look at what this looks like. Cool, and we go across to list files. There we go. That's all it is. That's the billboard. Right, that's the function, that's the struct. You register that into the LLM, and then you check the result of the inferencing, and then it will call that function. Right, so now we've got a list files. Like, this is the most baseline thing. To build a coding agent, you need to provide a layout of the file system to the LLM. So it knows what files in the file system, a repository layout, so it knows if you ask to read a file, like where those files are. Cool. So now that we have a list file tool, we need a read tool. Cool. So building upon that, is, hey, I have a riddle in a file called riddle.txt. Can you help me solve this riddle, please, Claude? So in this file system, I have a file called riddle.txt. It's going to read that file, and then it's going to allocate the result of that reading of that file, and it's going to use that prompt or that chat conversation I just had, and it's going to use that. It wants me to solve what this is. It's simple. I have a mane, but I'm not a lion. And it's like, the answer to the riddle is a horse. You are a horse. Sweet. And there's no magic here, folks. It really is this simple. If I have a look at read file, and come across here and then read, there we go. Here's the billboard. Here's the function. This is where you get into, where you start tuning a little bit of the prompt tuning and get into evaluation to improve the accuracy on different operating systems and different models, etc. So now that you have a read file tool, I guess what's the next thing you need for a coding agent? You need a bash tool, right? Because we can read a file, we can list the contents of the file system, but like, you need a bash tool. The bash tool is the thing that you can execute system commands with. So cool. This is the exact same concept from here. Bash tool. Hey, can you give me a summary of the top processes that are running on this computer right now? Just like by CPU usage. Top 10. And in here, I've just registered the bash tool. I've done this inferencing, and because I haven't tuned the prompt, this is a great example here. So this is what we do as tooling vendors. We look at these failure scenarios in each one of our tools, and we categorize why this happened. And this is how we adjust our system level prompts or tool level prompts to make sure that the first time you do a command when one of these things, like an edit file or a bash tool or what else have you, you get success, not failure. So normally we have observability of these things, and that's what we tune across operating systems, etc. Cool. Bash tool's done. You go to summary of the top 10 processes. Okay. We now have some of the baselines of a coding agent, right? All we need now is an edit tool. All we need now is an edit tool. And each one of these concepts stack upon each other. Each one of these concepts stack upon each other. Hey, can you create me a fizzbuzz application in Node TypeScript? Make it like fizzbuzz.js. What I want you to do is fizzbuzz up to 20. I want you to like run the Node application and like validate that it works. So this is going to take all the concepts. It's going to take a prompt. It's going to assign that prompt for inferencing. It's going to call the list file tools to learn about how projects are done. It is going to use the edit tool that I've just defined. And this edit tool will write out the logic of fizzbuzz. It will write me my package.json. And then it's going to execute the bash tool. And the bash tool will validate that the fizzbuzz works. Cool, we're now allocated, boom, done. We now have a baseline coding agent. We're under like 300 lines of code running in a loop. Hey, that's really cool, but I only want it to fizzbuzz up to 10. Can you like make that change to the code and yeah, can you actually run it again and validate that that change worked? This is all it is. Like when we're building all these tools, it's just these 3-4 primitives stacked together with a bit of tuning. And that's a coding agent. It really is that simple, folks. And we come over here and build it while I was talking. This is like the new norm. This is like the new baseline knowledge is like the same way knowing what a primary key is. You should know what this is in your particular domain. In your particular domain. There is an engineer that I caught up with last week. He's applied this knowledge in his domain in data science, and so far he's managed to automate the job function of 20 people, right? AI hasn't displaced them, no. It's enabled a really skilled engineer to be able to automate their particular things. That person is going to get rewarded handsomely for their thing. Your co-worker is going to take your job, not AI. So what do you do to fix that? Just invest in yourself, folks. It really is that simple. This year is a really bad year to be asleep at the wheel on personal development because you can do some really cool things with this. What I showed you was a baseline coding agent. You can apply this to your particular domain. And not everything can be solved by AI. Not everything should be solved by AI. But as you build your agents and you learn about this, you're going to develop nuance. Where is it okay to run an agent autonomously? Where do I need human in the loop? How many steps do I do? How many agent for agent? Like, what's the loss function? Like, the more hops you put through it, the worse results you're going to get. Start understanding and developing those type of instincts and to your domain of knowledge, and you're going to have a great year, folks. Thank you.